Okay, hello class. Thank you for your team intro NIT, MIT NSA problems. So that was really fun for me to watch. I hope you had fun doing it. And I just want to talk about some highlights from those. So again, if we were in a classroom, I'd be sharing this, we'd be maybe short little presentations. So I'm going to convey that information. I will be sort of the gatherer and conveyor of your guys' individual ideas. It looked like many of the groups had fun with this. So Brianna and Avery chose the NSA. A couple of their ideas that I wanted to point out, they spent a good deal talking about assumptions that they were going to make to solve this problem. And that's excellent whenever you're doing mathematical modeling, right? There are some assumptions that are being made. Be aware of what you're doing. Make sure you're going to communicate that to the client. They were talking about, are these nodes fixed? And am I only working on this graph? They made that assumption and then they went from there. And they talked about, I think their method could be classified as a brute force or total enumeration. They're going to start with a computer program that's going from O and then just branching out, following the links from that and from there and there, and you just get more and more paths. And then they go through and take all this long list of paths and they check the constraints. And then if for all the ones that did satisfy constraints, they're feasible, then they go through and run it through a minimization function and pick the best out of those. So excellent idea. And then you have to say, okay, that solved that particular problem. You go back to the client. Do you have other graphs? Then is this going to help? Is this, at what point does that idea fail? And then you have to go on to more interesting, tougher coding or more interesting mathematical models. But that absolutely solved the problem for this particular instance. Okay, another NSA was Maddox, Ashley, and Kristen. It was fun to see you guys all masked in the grad office together. They look like maybe there's some whiteboard stuff, but they also wrote on notes and they then scanned those. And so they had a screenshot that they were talking around, which is an excellent thing. I think this is clear by now, but the future of work is this sort of remote teamwork. So, try to use this as an opportunity as like, sort of polishing these skills that are going to be an important part of the workforce. So then things become seamless in the future, and you spent the learning curve now learning these things, and try to push yourself every week with just little things like that that can help with the team. Okay, I thought I saw someone else in another class do this. That seemed like a neat feature. Let me see if I can figure that out. You can always do the standard, the backup, and that's fine to submit. I'm just going to challenge you to look at this class as an opportunity, the way it's being taught in this hybrid style, to learn some new skills. Okay, so again, Maddox, Ashley, and Kristen, they did NSA. They spent a lot of time talking about the questions. They go back to the client, and they had some really neat. They broke it down by cases, I guess I would say. They showed 3 different cases that they were solving with a particular method that they had. But they really, one thing I liked about this is they talked about trivial cases. And so they said, I'd go back to the client and say, can I just take out this node? Can I just take out S and T? Problem solved, right? They asked if they could add links, because if you can add links, and what is the cost associated with it? So they just put a direct one straight from O to D. So they had a discussion about direct versus indirect links. They did a really nice job again with the technology, use of screen shares, teamwork. I love their vocabulary, just the way they talked about the problem. They used tons of words already that we're going to need in this class. And again, this idea of cases was really clever, I thought. Okay, let's do another NSA. That was May, Andre, and Zach. So May led the discussion on this one. They again had questions. One of their questions I thought was right off the bat showed insightful of the types of graphs. They said, is this a directed graph? So many of you just do the picture that I did, which looked undirected. So they go back to the client and ask that. They had some ideas, another brute force one, but then they went through a ton of graph theory and they just unloaded a ton of great ideas on us. Like they said, well, can we just adapt shortest path algorithms? Can we adapt a minimum spanning tree algorithm? Can we adapt connected graphs, finding the GCD, the greatest connected component in a graph? Can we adapt something from knowledge graphs? So trying to connect something to a standard problem, classic thing, that's something you should do. Hopefully you have a memory bank from other classes you've learned of types of problems. They talked about the adjacency graph associated with that. That then include them off to other things that use adjacency graphs. And then you do a lit review where you call a colleague and tell them your problem and do you think that fits? And Could I adapt? And that's a great place to start. They had a really clever one about entropy. I thought that was super neat. Oh, and then one of their first things they would do is a straightforward thing. They'd run a graph algorithm and just say, are O and D connected? You know, that's a very first thing. You might be dumped a giant graph and they're asking you to do something that's infeasible. So the very first thing they do is check, is it even O and D even connected? Okay, another group that did the NSA was Naomi and Olivia L. They did a really nice job. They jumped straight into the class. And I think this is because Naomi, of course, I think was the one that had the background, a little bit of background in LP. And Olivia is an awesome student. I'm sure she's already read ahead of the book. And they seem like, you all seem like you had a great time and you're going to be an awesome group together. They started modeling this. They were like, here's what I think the decision variables are. We're going to have, costs associated with each link. I need to know whether or not I'm keeping this link or removing it. So XIJs for every one of those. Maybe those are binary. XIJ is 1 if you keep it, 1 if you cut it, 0 if you keep it, maybe. So they started the modeling and they had a bunch of client questions as well. Here was a clever idea I liked from them. They thought about, so I showed you one instance of one network, and they took that instance and they said, could I extract 3 separate networks from this? This was my understanding of your idea. So I think this is what they're talking about. There would be one network which had information about the O and D. So included the O and D and maybe some links and connecting them. Then they had another network that had information about S. So maybe STIP and all its direct links. I don't know how far they went with the indirects. And then the same thing with the T. So these 3 different networks would then help them separate it and then distinguish so they answer these questions. That was a great idea. I loved it. Okay, and then let's go to the MIT ones. Only a couple groups looked at the MIT. So Chloe, Olivia, Michael S. Really nice presentation. And let me just, maybe I'll share the screen just to show, again, some things that you can do. Yeah, so they made a figure. They took one from the video I made, add some things, and then they started drawing through here, and just, this was a really great example of so when you can, again, that's another one where you're kind of pushing yourself with a little bit to learn some new teamwork tech skills. Okay, and within that, they talked about, they had a very geometric discussion. It seemed like if I was going to classify a summary of their algorithm, it was adaptive and maybe ad hoc, like they'd look at the graph that they were given and had this sort of geometric discussion. Well, they discussed the constraints and the different scenarios that they had, but their approach to me seemed like a geometric and adaptive method. Okay, the other group that looked at the MIT was Jenna, Preston, and Kevin. Okay, so a couple things they did right off the bat. They said, there's some things that are impossible. Let's just eliminate those. So like you cannot go through a no-fly. You can't exceed your fuel capacity. They had a discussion about the radar cost in that MIT problem. They were wondering, like, how bad is it if you go through 1 versus 2? Does it double? What's the discussion? They wanted to go back to the client and really clarify those sorts of things. Then I like this. So in general, I think this is great advice. And I think it was Kevin was the one that was leading this part of the discussion, was talking about when you have a problem, it often helps to think in extremes. So sometimes that's what is the easiest possible case, what is the hardest possible case, whatever the extreme means for that context of the problem. And so Kevin and his group interpreted this as, what's the best case thing? Okay, well, I've got a radar or a target in the middle. I want to drop some water over humanitarian aid. And I'm going to start over here on the boundary. Of course, a straight line is the best, and then a straight line out. If the plane has this super tight turn radius, maybe just go in and out. And so that's your ideal. And then he worked from that and said, like, how far are things off from that? If I can easily get in and get out and measure, and then Preston went in the discussion, okay, well, I take that best case, maybe, and that straight line goes a little bit on the edge of this radar and a little bit on the edge of that. Preston's discussion was, can I get more information from the client to clarify the various objectives or the weights associated with perhaps going through a radar versus the shortest path. Like, which one do you care more about? Is it okay if I spend a little more in fuel if I, instead of going straight, I like just a little curve around, just around the edge boundary of that radar, and I've satisfied that constraint in the minimal way. So excellent ideas and discussions there. Again, in general, I really enjoyed listening. So thank you guys for making them. Oh, and there are no team names yet. What? Is it because you're in grad school? Nobody uses those anymore. Okay, well, again, hope you're having fun. I think it's going to be a super fun semester. You're going to love the topics. I feel like I just got a feel from y'all that you really like sort of the applications, but for our theory folks, there's some of that too. There's going to be plenty of getting into the nitty gritty of the algorithms. All right, have fun this week. And again, thank you for sharing your homework. I enjoyed it.